Hi folks, in this little short we're just going to talk a little bit about databases, and we might just get into a little bit of, storage type talk. Let's do this thing. Alright, so in the last couple of shorts we talked about an introduction really to the kind of things that information systems are, people, process, technology and stuff like that. We talked about the technology bit, we talked about data and information and knowledge, and so on. It was great fun, wasn't it? This time round, databases, and more specifically relational databases. Why do we need databases anyway? Well, frankly, to store data, but also to give us the opportunity to analyze, query, protect, structure data in ways that make sense to us for the stuff that we're doing. So let's start with what they are. A relational database is a database of tables. A table in a database is a collection of records. A record in a database is a collection of data elements, if you like, bits of data that represent something. So for instance, you could have a student record which has your student ID, your first, middle, last name, for example, your address, maybe your address on campus or your address in town, or maybe a telephone number. All of those different things are little data elements. And so each record contains all of those little data elements. Sometimes there isn't an entry for a data element. For example, maybe you don't have a middle name. Maybe you don't have a cell phone. Maybe you don't have a landline. All of those things. But that's okay. All of the elements in a record are there, whether filled in or not. And a table is just a collection of these records. So if you're familiar with spreadsheets, you've got rows and columns. Yeah, rows that way, columns that way. Each row in a spreadsheet looks kind of like a record if you have different things associated with each element in each column. So you can look at a table in a database as kind of like rows of tables, each of which has got columns associated with specific data elements. I'll show you a picture. So that's a database, but why is it called a relational database? I'll tell you. It's called a relational database because you can have tables relate to each other using things called primary keys. So each one of the tables you can create a primary key. For example, let's use your student ID as a key. So in one database table, that primary key or student ID is associated with the stuff I just talked about, your name and address and all that kind of stuff. In another table, that could be associated with your financial details. In another table still, that could be associated with your courses at present, the ones you're taking this semester. And in a still further one, it could be a record of all of the courses that you've taken for each semester that you've been here, and so on and so forth. Creation of relational databases and all of the different tables and their structures is actually something of a science and an art, so we won't go into it here, but the point is that we use the student ID in each one of those tables to refer to the same thing, which is you. And each one of those tables can therefore be said to be related to each other using that key. Hopefully that makes sense. So you can actually perform queries, and we use something called, in most databases, we use something called SQL, Structured Query Language, to query all of these tables using that one key to get lots and lots of different kinds of information in lots of different kinds of ways. Lots of views on the same kinds of information. So that's a relational database, and I'm sure that you can think of lots of other different examples of where that might work. And it just doesn't just have to be a student at a university. It could be somebody paying taxes, and maybe the CRA's got some databases and different structures and so on. It could be from when you were in school, where your school board maybe has databases associated with you. What would the primary key there be, do you think? So yeah, relational databases, very interesting, very huge field. And if you carry on at Ontario Tech, you'll find out a whole bunch more about them. But the main thing to remember in this particular instance is that a database contains a whole bunch of tables with structured information in them, and each one of those tables can relate to each other, or none at all. They don't have to be related to each other at all. The key there is that it structures the data, it holds the data in a specific way, and database management systems perform all kinds of stuff, not just the structure, holding the structure together and storing the data and making sure that it's protected so you can log into the DBMS and see your stuff and backed up and all of the stuff that you want from a secure structured data type thing. That's what DBMSs do. And as a user, you might query it using the SQL language, or you might have an interface given to you which allows you to perform specific kinds of queries which are already built for you, and so on. When we do our SAP stuff and when we talk about ERPs a little bit later, you'll hear a bit more about that kind of stuff and databases and how that might work. But in the meantime, I think it's worth talking very briefly about what kind of data elements you can have inside a database and why that matters. So here's the thing. Memory costs money and storage costs money, so it would be sensible to manage it in a way that limits the amount of the money you're going to be spending on these things. One of the things that you can do is dictate which data elements in those databases that I was talking about have what kind of structure. That doesn't just help you with the management of memory, by the way. It can help you with things like queries and comparing one thing to another thing. You can't compare a student ID to an address, for instance, because a student ID is a number and an address is text. So there are various different kinds of data that we can talk about inside a database. What might they be? These things are called data types. Here goes. The first one is just text, usually around 256 characters for various reasons which we don't need to go into, but unstructured apart from that, just text. The second is just numbers, for storing numbers, and they have different kind of data types depending on the size of the number and whether you need decimal places and how many decimal places you need. Another one is basically Boolean, a yes or a no, or a 1 or a 0, or a true or false. And really that only requires one little bit of memory to store it. We'll get to what that means in a second. The next one is a date and time, which is basically stored like a number, but interpreted by the system as like a date or a time or both. So for example, 2022 09 23 09 00 could be 9 o'clock in the morning on the 23rd of September 2022, if you see what I mean. And then we have currency, which is 2 decimal places, numbers with 2 decimal places, specifically holding money, figures for money, followed by paragraph text, which is text that is longer than 256 characters because you can make it an arbitrary size that will hold whatever you want in terms of text. And finally, we have just a generic object. For instance, you might want to store images. You might want to store some movies or sound files or whatever, which you don't actually know the structure of and the size of and so on. We don't need to go into the details of how that actually works. It's just enough to know that an object is something that you can store in a database. So we've got a whole bunch of different kinds of data structures, data types that we can store information inside our database. And that helps us with things like queries, with things like displaying results, with things like ensuring that the right data is put into the right fields so you can actually test to see if people are putting the right stuff into the database and not trying to mess it up and so on, which is a great help, especially if the database is online. All of these different things can be allowed or made to happen because you know what kind of data types you want in your database and you've set it up that way. Now, I did say I'd talk a little bit about storage, but this short is already 10 minutes long, so I'm going to do it in another short. I'll see you there.